All right, so my name is Dave Chanel. I am the team lead of CyLAR, and I'll let the rest of my group introduce themselves.
My name is Simran Singh, and I'm a junior in aerospace.
I'm Scott McCleary, and I'm a sophomore in aerospace.
I'm Chris Ziegler, and I'm a junior in aerospace.
And as I said, we are CyLAR, and our project mission is to research and design a linear Aerospike rocket. So a brief overview behind the project. The classic bell nozzle engines have limited efficiency in terms of traversing large ranges of altitude, and the research that has been done on Aerospikes has shown them to be more efficient at more variant altitudes. And so we are attempting to generate and maintain further interest in Aerospike engines, as well as in the future possibly generate an engine with the purpose of optimizing it for efficiency.
So this semester we have selected the solid fuel compound that we plan to use. We've also selected the plug geometry and the ignition system, and currently researching the nozzle design.
So for the ignition system, we're choosing to use a bridge wire ignition method, which involves taking a wire, running it through a pyrogen, which will quickly ignite the top layer of the solid fuel, all of it at once, so we can get a clean, even burn. The advantages of this are having an even ignition, and it has a simplistic design. However, upon ignition, the wire and pyrogen will be destroyed, so we have to replace that each time, as well as having the pyrogen burning in there might disrupt the flow of the fuel, which could disrupt our results. In the future of CyLAR, we do still need to design the energy release system to actually get a current to the bridge wire system, as well as design the hardware to physically attach the ignition system to the rocket and make it so the hardware and the energy release system can survive in the environment it will be in. So we only have to replace the bridge wire as opposed to having to replace the entire ignition system after every use.
And for the rocket fuel, we're going to use KNDX, which is a chemical compound containing potassium nitrate and dextrose, which is a common sugar. And that will be at a 65-35 oxidizer to fuel ratio. And those compounds are easily obtained through pharmacies or other sources and for pretty cheap. And we can either use the dry compression method or the dry heating method, and we'll use the dry heating method because it's safer and it'll be easier to do. And as you can see from the graphs here, the red is a sucrose, and then the blue is the dextrose, which we're going to use, and it has a nice neutral burn that will burn over a longer period of time.
And the plug geometry we have chosen for our solid fuel is a 6-point truncated star. And the idea behind this is we're trying to keep a nice neutral burn in order to eliminate certain variables during the performance of the rocket. And from this graph here, you can see the different ways to optimize a 6-point truncated star. And again, as I said, we're going to try and keep the neutral as possible when we go through optimizing it. The current state of the design, as we've been going through, we have been focusing on safety with our designs. That is one of the main reasons why we switched to solid fuel as opposed to liquid fuel and oxidizer. And we have been also looking at different fuels in terms of their safety to handle as well as their cost, which is another reason why we've selected this fuel. This semester has been mostly optimization of the fuel plug, the fuel itself, and the ignition system. Next semester, our plans are to begin 3D printing certain aspects, to begin flow testing them, and compare that experimental data with analytical data that we have already optimized, as well as beginning to test the fuel and see if it performs as we expect. And our timeline basically is that now that we have chosen the solid fuel and selected the exact composition we're going to go with, we can now finalize the rest of the designs in terms of the combustion chamber, which we had designed for liquid fuel and oxidizer, but needs to be redesigned with the alternate specifications of the solid fuel.
So this semester is strictly design and optimization. It will be mostly R&D. Therefore, we require no funding for this semester. Our budget is 0.
And as we said, the current state of the project so far this semester has been further design and optimizations, focusing on the fuel and its ignition. And now that we have selected the fuel, we can begin to further optimize and design the remaining subsystems. And our future goals are to continue to finish designing the aspects of this engine. And for future goals of this team, CyLAR, ideally would be to design a full-scale rocket in order to test this engine at the multiple altitudes and see if it does, in fact, show its efficiency as it should. Thank you.